right. Did you guys enjoy the movie? Yes. Of course, keep in mind that's almost a 50-year-old movie. Movies are a lot better now. I'd like to bring to the stage our very special guest, Dr. Caroline Morley. Come on up, Caroline. All right. Did you enjoyed that documentary, I think?
Yes,
I hope,
yes, very much so.
Now, of course, that is a work of imaginative fiction. It is not intended even to be scientifically true, in fact. But you do work in the field of astronomy, and what I was going to ask was and we are all fascinated by the sort of what's out there portion of it, even if as lay people we may lack an understanding of the scale of the cosmos, which is a thing that I don't quite understand, because I've heard that even if you were just to travel to Mars, you would have to it would take such a long time. Can you give us some sense of what would be a plausible travel time to Earth from a theoretical inhabited body in the closest faraway solar system?
Yeah, absolutely. So the stars are unfathomably far away. So when I teach this in my class, I always make a scale model of how far away stars actually are, because it blows people's minds. So what we do, we take a beach ball, something like this size, size of my arms that I can carry, put it on top of the UT tower. We just do this in our minds, not really. We can't get to the top of the UT tower. And then all of the inner solar system fits on the plaza in front of the tower. Jupiter ends up in the football stadium. Okay, picture that. Pluto ends up on the Congress Ave Bridge. The furthest spacecraft we've ever sent away from Earth. Anyone know what spacecraft that is? Voyager, wow. Yes, is at about the Austin airport. How far away is the nearest star? Any ideas? I'm hearing Houston, France. It is all the way across the entire Earth in the Indian Ocean on the other side of the planet. And so we have gone only a tiny fraction of the distance as Earthlings to our nearest star, which is Alpha Centauri. Because of that, we measure distances to the stars in light years. Light, right? Light, like this very bright one right here, travels at a finite speed. It takes a photon of light over 4 years to reach Alpha Centauri. And so what that means for us is we would need, if we want to get there in our human lifetimes, we would need to be traveling at something close to the speed of light, at least a healthy fraction of the speed of light. With our chemical rockets, the ones we have now, we can fly. Voyager is flying at something like 16 kilometers per second, which sounds fast, but it would take Voyager 40,000 years to go there. It's actually not going that direction, so it won't get there. If we built the best possible theoretical chemical rocket, it would take about 4,000 years to get there. And so we have to be clever, and people have thought of really cool ideas like chucking nuclear weapons out the back of your rocket. They explode, they push you forwards, you get that momentum. That could actually accelerate you something close-ish to the speed of light, maybe 10% the speed of light. And then our other trick is making a very small spaceship, shining really strong lasers at it. That could maybe get you, because you don't have to carry the fuel because you're shining the laser, something like 20% the speed of light, get you there in something like 20, 30 years. So that's as fast as we could possibly get it. And so we can't just zip back and forth between the stars very easily. But
that knocks out so much of the premise of this film then. Because those aliens did not come from inside the solar system, I don't think. We would know. We know, right?
Yeah, we know if we've mapped the sky really well. We'd know if there's something like that floating around close to us.
And we'd know that if there were habitable planets. So how unusual, I will ask, is the Earth's atmosphere? And how would we know if one of those faraway planets that we can see but can't quite get to, how would we know if there's something that might be what we would consider habitable, and how we're while you're answering this, tell us a little bit about how you're studying this.
Yeah, so we're studying this right now. This is a question that basically we don't know the full answer to yet, but we would love to be able to learn the answer to this in our lifetimes. And so we're looking at mostly the atmospheres of these exoplanets. We know that there are thousands of exoplanets that we've been able to discover. We know that exoplanets are very common. Earth-sized exoplanets are very, very common around most of the stars that you see in the sky. We haven't yet been able to make the super precise measurements that we need to make to know whether they're inhabited or not. That's the goal of like the next 30 years of exoplanet research, is to figure that out. So when we look at their atmospheres, we're basically trying to detect the same kinds of molecules that we have in Earth's atmosphere in these exoplanet atmospheres. So right now we're using the James Webb Space Telescope to try and see atmospheres like Venus-like atmospheres with lots of carbon dioxide in them. And then with future missions, we really want to be able to discover things that are only made by life. And that's how we would tell that something is actually inhabited versus just has the right, temperature close enough to its sun to be inhabited, but not too close so all the water evaporates. We want it to be just at the right distance. So things on Earth that are these biosignatures, signatures of biology, are oxygen, right? So plants make oxygen here on Earth. Methane is also a biosignature. Bacteria, cows, all of those things make methane. And so we're looking for some of those combos of gases that we would not be able to make unless we had active biology happening on those exoplanets. And so we have a path forward for being able to do this with NASA. So NASA is it's just launched a project office for the Habitable Worlds Observatory at NASA Goddard. And so we're hoping that NASA continues to be funded so that we can continue to kind of build this project, which would be a space telescope that would launch in the 2030s to answer exactly this question.
And that telescope, it would be able to look at the planets and look at the diffusion of light to detect what gases might be there?
Yeah, so Habitable Worlds Observatory would look at reflected light, so it would be able to see the same kind of visible light that you can see with your own eyeballs. We're looking for that light that's coming from its star, bouncing off the planet, and coming to us. When it bounces off the planet, all of the molecules that are in that planet's atmosphere absorb some of the light, and so we can see kind of the signature of that absorption.
That's so interesting. And in just a minute, I want to get some questions from the audience, so you guys start thinking about some of the questions that you may have. I am curious, though, like, you're a part of the professional cohort of astronomers, of course. Would you say that most of your colleagues, and also throw in your own opinion here, believe that what we think of as life is likely elsewhere? And what would you expect a likely contact point to be if there is life out there?
Yeah, I would say that in my field of exoplanets, where we're sort of dedicating our whole careers to studying this topic, I would say that we are optimists. That I think most of us think that there is life out there, and we only have more reasons to be optimists now than we did even when I entered the field in 2010, not super long ago. But because we found so many planets and we know that planets are so common, we didn't know that when I first got into the field. We had only kind of touched the surface of the kinds of planets we could find. Now we know they're everywhere. So we just have to have the right telescopes to be able to see them in this detail. So I think life is out there. The big question to me is life like us out there, right? Are there kind of technological civilizations out there? I think that's a much more uncertain question, but I would bet a lot of money that there's biology happening elsewhere in our galaxy.
That there are life forms that we wouldn't even have a clue as to theoretically what kind of life forms they are. They're probably not going to have 2 arms and 2 legs.
Yeah, probably not.
Probably, but who knows?
I don't know. There's an idea of convergent evolution, right? Where if we have the best body plan possible, then you might have lots of different paths of evolution that get there. But it's not obvious that we have like the best possible way of forming life.
Absolutely not. Most of us, anyway. I'm wondering if we have any good questions for our audience. There's no bad questions, I don't think, but we'll find out. Right over here, yes.
I'm kind of curious. You mentioned something about looking for other planets that kind of have very similar configurations to where we are, and of course, we are looking for life like us. Are there any theories around certain configurations of elements and temperatures and atmospheres that might lead to other kinds of life that we haven't thought of yet? Are there any theories around that?
I'll repeat for the benefit of people who didn't hear that. Are there any theories about particular confluences of minerals and gases and so forth that might sustain a different kind of life? Is that more or less? Yeah.
Yeah, so the kind of traditional way of thinking about where life forms is you're looking for places with liquid water. Water is such a good material for being able to have chemical reactions in there, to be able to build cells out of water. It's also an extremely abundant molecule in the galaxy. And so those are all really good reasons why we focus our search on places that have surface liquid water. It's important that it's on the surface because we need to be able to see it from space, right? Whereas in the solar system, we can like drill into Europa and try and find life like under the ice in Europa, there's liquid water. So in the solar system, we have lots more options of places we can look. One of the other cool places in the solar system that we're looking for signs of life is on Titan. Titan is a moon around Saturn. It has a nitrogen-based atmosphere, just like Earth does, but instead of water, because it's so cold out by Saturn, it actually has like pools of hydrocarbons like methane and a whole like hydrological cycle, but it's not hydro because it's not water, it's methane. Methane is raining on Titan. And so that's really cool. Anyway, we're sending a quadcopter there called Dragonfly. And Dragonfly is going to look to see what's going on the surface of Titan for the first time, possibly to, if there is life, trying to detect that, but otherwise doing really interesting studies of what that is like. So I would say that in general, we're looking for surfaces with liquid water, but I would say that we are open to all possible ideas, and we're always looking for molecules that like shouldn't be there together in any planet we're looking at, because that might tell us that there's something that's not like normal geology, normal chemistry going on. There's biology, which makes way wackier and weirder things than just geology and chemistry.
Awesome. I see a hand right over here. So what's the possible timeline for finding out what's going on under this methane rain?
Timeline for like Dragonfly and I should know this better than I do, but it's very much in the building phase now. It's all funded so far, and so they're working on. I know, right? They're working on building it, and they have a launch window that is it's within the next 10 years. I don't remember exactly when it is, but I think it's like late 2020s. It's gonna launch, and then it does take time to fly to Saturn. It's one of the things that planetary scientists have to be really patient.
I see a hand right over here.
In the film, there were those guys in the red suits who are like, I guess, intended to be like designated to like talk to the aliens and stuff. In real life, is that like a thing? Like, are there people who are on reserve just so they can like have like these are the ideal people to talk to the aliens and stuff?
Are there? I'll repeat the question. Are there real red suits, people who are like alien communication specialists who are deployed and ready to go and presumably paid by the government?
I think no, but I mean, this is not a scientist question, right? Like scientists are not those people, in part because we are many things, but one of the things that we are is very bad at keeping secrets. We're just so excited. We're so excited about science. We're so excited to talk to each other about science. Nobody ever taught us in like our training how to keep a secret about science. We just all, post our papers everywhere and tell the public everything. And so we would not be the right people to be in like a secret organization that is designed to talk to the aliens. There are definitely people who are thinking about what happens if we have first contact, right? And what that should look like from a scientific perspective, but I don't think there's any kind of overarching kind of organization that controls that right now.
I was really hoping because I'm looking into that as a career option.
Yeah.
Yeah. Start with the red suits, and then maybe the rest will follow. We'll see. I wonder if we have any other questions or contributions. Yeah, I see a hand right back here.
Speaking of our limitations with chemical rockets and things like that, one, could you speak to the lasers that you were talking about, and are there any other advancements that are very exciting that could help us get further or study better?
I'll just repeat the question. I think is you talked a little bit about laser propulsion. Are there any other exciting new ways that we might get there faster? And I'll throw in quantum engineering into that question too.
Yeah. So the lasers are fun because so there was a a Russian billionaire guy who was interested in this and interested enough that he gave lots of money to a few people to think about this from a science perspective and from an engineering perspective. So the idea was called Breakthrough Starshot. The money is cut off. We're not thinking about it anymore. But nonetheless, still interesting. See, scientists, we're just excited. And the idea is you would make the camera in your iPhone kind of size camera. Your iPhone camera is great, right? So let's just send that, which is very small, to Alpha Centauri and take pictures of the planets that are there. And so you make this nano-sized spacecraft, and then you just need a huge array of lasers on the ground that can take the whole amount of energy that's possible to make on the Earth at one time, shine it into the nano spacecraft, and then you can accelerate it up to some fraction of the speed of light. So there is a few kind of technical challenges that would need to be overcome to do that.
And funding challenges, I would think.
Some funding challenges too, yes.
That would be interesting. Yes, I see a hand right here.
Yeah, I have a question. I just reading up Christopher Nolan biography and thinking about Interstellar and black holes and all the science fiction stuff that he deals with. And I was curious, what was the intersection that y'all work with theoretical physicists when thinking about time travel and space travel? I always know there's always that sort of idea of using black holes to travel across space, and what is the theoretical possibility of something like that happening in the next I don't know, hundreds of 1,000 years or whatever? What is that possibility like?
So I'll repeat. I think I got this. We'll use black holes specifically here as an example. What is the possibility of kind of using black holes to sort of slingshot to the outer reaches of space?
Yeah, I think that the possibilities of that from a theoretical physics perspective are that we could do something like that, but it would be sending a single atom using a black hole that we create, and it would send a single atom. And I don't think we would know exactly where it would go, but something like that.
But it would sure have fun.
Yeah, I don't know. We definitely would not have fun. So if we went to a black hole, there aren't any nearby black holes. It's actually way harder to get to a black hole just because they're really far away. But if we did go to a black hole and tried to jump in, we would be stretched out. We call it spaghettification, which is one of my favorite real science words, because you get I guess if you jump feet first, right, you're getting longer in that direction, and you get ripped apart before you can actually jump through the wormhole to somewhere else. So the possibility for actual macro scale squishy things like us to get through is very low.
Damn. Right over here. Okay, I knew we would have questions like this. Have you ever had a close encounter?
Alas, I have not, but I always have my eyes peeled for something.
Yeah, because you're always looking at the sky.
I really am. Yeah, I'm one of those people who looks out of the airplane window. I actually study clouds as my micro specialty within exoplanets. So I always look at the clouds and I'm like, oh God, those are so much more complicated than the clouds in my models that I run.
It's not such a nutty question, to be honest, because you're looking at telescopes, you're looking at the sky. You're if anybody's going to see it, it's probably going to be somebody who's looking up through that stuff. And you've never seen an anomaly. Have you talked to anyone who's seen an anomaly that would fit roughly into that kind of space?
So people who use radio telescopes think about this the most. My favorite example of this is they had a signal that they just couldn't figure out at one of the big radio telescopes in the US. And it was like not on any specific time scale. It didn't seem like it was connected to any specific astrophysical object they were looking at. Eventually they figured out what it was. So astronomers, right, when we're observing at night, we drink a lot of coffee and we make ourselves a lot of like ramen noodles in the microwave. And it was somebody who, instead of waiting for the microwave to be like done and then opening the door of the microwave, was just like opening the door of the microwave, and like the microwave turns off, but not fast enough. The radio telescope caught it. And so every time somebody would open the microwave, the radio telescope would be like, aliens.
You have to wait for it to stop? You have to wait for the bell to ring? You can't just open it?
Yeah, you should really wait. Yeah.
Now you tell me. I wonder if we have maybe one or two more. I see a hand right over here. Yeah.
Just wondering, in your career, from when you started until now, what's been the biggest discovery that's amazed you, or just the community that you work in?
Yeah. So
I'll repeat. What's
Yes.
been the most amazing discovery in your career?
So the thing that really changed how I think about planets is the very first results that came from the Kepler Space Telescope. Kepler just looked at like one patch of the sky and looked at the stars over and over and over again to try and discover planets as they happened to cross in front. And before Kepler launched, we didn't know how many planets there were in our galaxy. And then I was in like my second year of graduate school, and our knowledge of which planets were there totally changed. So we imagined we had found some unusual planets already. We had found some like hot Jupiters, which are Jupiters but in like 3-day orbits whipping around their stars. Most of the planets we found had been like that. Kepler found all of these planets that were between Earth size and Neptune size. There's nothing between Earth and Neptune size in our own solar system, right? If you've ever learned about planets in grade school, it's like, okay, you got your rocky planets, then you got your gas giant planets. You don't have a whole spectrum of things in between, but those turn out to be the most common planets in our galaxy. And so we still have this big mystery of what exactly are these? We call them either super Earths or sub-Neptunes because we're very creative at naming things. And we're still trying to figure out what they're made of. And so this still like drives a whole bunch of research that I do and I think about even today with the James Webb Space Telescope that we're using right now.
There's an elephant in the room, which is that funding, you know, the government funding, particularly scientific funding, seems to be in jeopardy. This isn't strictly a scientific question, but you're somebody who works in the field. What's going on? What are the anxieties or the reassurances that are out there in your field right now about that?
Yeah, I mean it's something that's impacting all of us. Literally every single day, I open up my funding spreadsheet and like there have been no calls for funding this year, right? Usually I spend the whole month of May after the semester ends writing proposals to be able to fund real people who work for me, right? Who work in my group, my students, my graduate students, my postdocs. They're funded to work on projects, right? To do science. And we're usually able to write funding proposals, compete them. They're very competitive to get. And so it's a very meritocratic system. There have been no calls for funding this year. Everything has been cut off. So from my scale, right, as like one person trying to run a research group, we're anxious. On a macro scale, I just visited NASA Goddard last week, where they've built a whole space telescope, the Roman Space Telescope. It's built. They built it. They're testing it. They're not sure they're going to fly it. And so we're nervous on a macro scale as well. And so I think there's no reassurances right now. But if anybody cares about science, call your senators. Right? Ted Cruz is on a big science committee. We talked to some people from Senate Appropriations a few weeks ago. I gave a talk to them. They seem on board with science as a concept. And so, yeah, call your House of Representatives, Congressman, because, otherwise, science will continue to happen, but it won't happen in the U.S. It'll happen in Europe. It'll happen in China. It'll happen in other countries. And so if we want to be part of it, we should fund it.
Yeah, no, I think that's an amazing point. And I'll say this, for those of you who are like, oh, I'm going to call like Ted Cruz, I'm going to call John Cornyn. Yes, actually, you should, because you think like, oh no, they'll never get it, they'll never go for it. They're awful people. They're not. They're actually, maybe they are, but they're also anxious about and they're going to listen to reason. They're anxious about their funding. They're anxious about their votes. So actually do talk to them and be polite when you call. But like, get on the phone and talk to them. They'll get the message. Actually, I saw a hand right over here. Yeah. Okay, I'll synopsis. Entropy, fact or fiction?
I do think the paradigm has changed on that in recent years, and we're not going to have like the cosmic death where everything just expands forever. I think we're slowing down now. So yes, I think that's right.
Woohoo! All right. Let's get one last question. This has been you've been amazing. You're so good. I wish I was taking your class. I see a hand right over here. What are your thoughts on Dyson spheres? Yes.
Yeah. What are my thoughts on Dyson spheres? Yeah.
And what are Dyson spheres?
Yeah. So Dyson spheres. So the idea is your alien civilization starts to run out of, I don't know, the fossil fuels that they've been burning on their planet or whatever. And so they need to harness more energy, maybe to power all of those lasers that they're using to accelerate their rocket ships. And so they build like a sphere around their star to be able to capture like a big solar panel, like a really big solar panel. The reason why we might think about this, right, in a theoretical sense and in a can we discover this kind of sense, is that if you build a big sphere around your star, it starts to glow in the infrared. And so we can look for that. We can look for something that is like anomalously glowing in the infrared because it's heated up, and we can potentially see a signature of that. We can also potentially see other, like we call them mega structures, so like big sets of spaceships that aliens have built around their star. So we can look for those as well. We haven't found any of those specifically so far, but every time we see something kind of weird, we go and look at it again, usually with like another telescope at a different wavelength of light, so we get more information. So far, everything has been astrophysical, but we keep our eyes peeled for anything weird that we see that might be something like that.
You know, I got to be like Columbo here and ask one last question, because I've said that several times already. But so a lot of times when we're looking at these other planets, it's not so much is there life on these planets. I suspect we're looking at them going like, could we, if we needed to relocate, could we relocate to another planet? We got this perfect planet that we ruined. Are there any other perfect planets we could ruin?
Maybe, yeah. We're trying to figure that out now. So we don't know exactly what the environments on those other planets are like, but I think personally we should take care of the one that we have, because it'd take us a really long time, and a lot of those
That's a radical
lasers,
idea.
Yeah.
Yeah.
Let's take care of the one we have.
We literally live on the heaven planet. And like we're screwing it up every day. It's amazing. We're so dumb. Not us. Everybody outside this room is so dumb. Everybody in this room, I would say pretty smart, especially Dr. Caroline Morley, who joined us and answered so many questions and was so great. Let's thank Dr. Caroline Morley. Let's thank the Sloan Foundation for making Science on Screen a thing. And I want to thank all of you for caring enough to stay up this late on a school night watching one of the greatest movies ever made. Thank you all. Good night.